Hello, this is Study Chem E tutorials. In this tutorial, we are going to solve for the first moment of area and the centroid of the figure on the screen. This figure is a composite figure of three main shapes, shape A, B, and C of different dimensions. This makes this figure a non-symmetrical figure. Therefore, we cannot say that the distance of the central point in the figure B from the axis SS is a centroid. We need to calculate the centroids for all of the shapes, and then from that we can calculate the centroid for the composite figure. We also need to calculate the first moment of area for each of the shapes and add, and that will give us the first moment of area for the composite shape. So we have seen that the shape is not symmetrical. We have to calculate the centroid for each component shape. You are advised to use what we call systematic tabular method. This method helps you not to skip a step or miss a point. You are able to calculate each individual item, and at the end you find the total, which gives you the total first moment of area from which you can calculate your centroid. So we construct a table. The table have a column for the particular component, area of the component, the centroid of the component, and then the first moment of area for the component. The composite figure has components A, B, and C. Now we have to calculate the area for each of the components. From the figure, component A has the dimensions 10 mm by 40 mm. So we can say that the area of component A is 400 mm. Component B has the dimensions 10 mm by just 40 millimeters as the height for component B. So we can say that the area for component B is 400 millimeters. The component C has the dimensions 10 millimeters by 300 millimeters. So that gives the area for component C as 300 millimeters. The total area will then be 1100 millimeters squared. Move on to calculate the distance of the center of each of the components from the axis SS. For the component A, half of its height is 5 mm, and the total height from its tip to the axis SS is 60 mm. This gives the distance of the centroid of A from the axis SS to be 55 mm. Then when we take the component B, half of its height is 20 mm. Its total distance from the axis SS will be 20 plus the height of the component C, which is 10 mm. So that gives us the centroid for the component B to be 30 mm. And then when we take the component C, half of its height is 5 mm. From the axis SS, it's going to give us 5 mm. So we fill our table with the values we had for A. The centroid of A was 55 mm, that of B was 30 mm, and the C was 5 mm. We find the first moment of area for each component by multiplying its area by its centroid. So for component A, 400 multiplied by 55 gives us 22,000. For component B, 400 multiplied by 30 gives us 12,000. And for component C, 300 multiplied by 5 gives us 1,500. So we get the total first moment of area to be 35,500. So therefore, the first moment of area for the figure is going to be the 35,500 millimeters cubed. Since we know that first moment of area is equal to centroid multiplied by the area of the figure, we can say that then the centroid for the figure will be the total first moment of area divided by the total area of the figure, and that gives us 32.27 millimeters. Anytime you are solving first moment of area or centroid problems for composite figures, it will be very easier and simpler for you to use this systematic tabular method so that you don't leave anything out and you don't find yourself wanting at the end. If this is your first time of visiting Steady Chemical Engineering channel, make sure to subscribe for more other important tutorial videos that are upcoming. My name is Joe White, third year Chemical Engineering, Kwame Nkrumah University of Science and Technology, Kumasi Campus. This is a part of the Franklin's Learning Initiative. Thank you for watching.